Good morning, everyone. Welcome to day 14 of writing a TCP/IP application. This is the second bonus day, one I wasn't really planning to do, but some very astute watchers of the stream had noticed a bug. So let's go ahead and jump right into it. I'm going to talk a little bit about the bug today, and then I'm going to do something which I really should have done from the beginning, and that is add some unit tests to our parsing code. So here's the bug report. Thank you, Michael. He's one of the regular watchers I know. And then Freddie also jumped in and helped diagnose what the problem was. And then I put out a fix. The fix is here. I put out a fix like right away, just in case somebody was going to use this code for something. I wanted to make sure that the code was actually correct. And even though this fix works, I could make it a little bit better, and I'm planning to do that today as part of fixing it properly. So what I'm actually going to do is probably back this out, and then add some unit tests, and then put in a more proper fix. So the underlying problem was actually, I was calling, I don't know if here, it's change this to split. There we go. So originally the code, as of my last video, was doing this, and it's been doing this since day 3 apparently, and it was when the bug was introduced and I didn't notice. So so this code will fail if there's more than one message in a single packet coming in, or a single read. Sorry, a single stream read, a single socket read completing that has more than one message in it, and it'll fail because it'll come through here and say, I've got some more stuff here, I can read this entire message. It successfully reads the message, adds it to the result, calls advance to, and this is the problem because it's calling advance to on each message, because then it'll loop back through here again. If it successfully reads another entire message, it'll call advance to again, and that is the incorrect behavior. Pipelines have this ping pong kind of API where you get a memory buffer, then you call advance to once, then you get another memory buffer and you call advance to once. So the fix for this that I put in is pretty simple. It just moves the advance to call. It actually combines these two advance to calls and moves them outside of the loop, so it's only called once. What I really want to do is actually today move this advance to up to where the memory call is, and that way it will. That way you can see that ping pong much more clearly in the same method, right? So the get memory and the advance to are in the same, or not the get memory because we're reading, but the other one, where you essentially get the memory buffer out of the pipeline and then call advance to. That those two are in the same method, so it's very clearly there's a one-to-one correlation between them. And this is documented very well. I think that the error message is a little bit obscure. It says no reading operation to complete. It's not the greatest error message. So I might open an issue on the .NET runtime after this, just asking for a better error message. But the documentation itself is very clear that this is not allowed. The buffer previously returned from read async, that's what it is, read async, not get memory, must not be accessed after this call, which I was completely not doing correctly. Yeah, so unfortunately these remarks sometimes include some very valuable, necessary information, but the remarks don't show up in IntelliSense. Only the definition up here shows up in the IntelliSense. So, oh well. It is what it is. So it is well documented. I just didn't read the documentation. My bad. All right, so let's go ahead and add a unit test library, and I'm actually going to be using. So I like unit or xUnit for my unit tests. Totally a matter of preference. But I tend to prefer xUnit. I know that a lot of people on the .NET teams use xUnit as well. So it's very, I don't want to say well maintained, but it's very tight to that .NET ecosystem. And I'm going to be using a tool called live unit testing, which a lot of people may not be familiar with. Unfortunately, it is only available in Visual Studio Enterprise, and which I have, obviously. So I know it's a tool that a lot of people don't have, but wow, this is the one feature of Visual Studio Enterprise that I use way more than any other feature in that Enterprise edition. To me, this is like the killer feature for Enterprise. And essentially what it does is it rebuilds your, so it runs your unit tests once, compiles them and runs them, and then it also analyzes them. So it does like full code coverage and everything. And then it also keeps them in memory. And what it ends up doing is as you're editing your code, it uses Roslyn all in memory to just recompile that part of the code that you changed and determine which of those unit tests actually need to rerun and automatically rerun them all in memory. So it's very fast. It is still a little bit of a CPU hog if you have a lot of tests, but overall, wow, it's this amazing tool. So let's go ahead and get started. I'm gonna kick off actually I'm gonna back out this bug fix first. Yeah, I'm gonna do that. So I'm just gonna say, yeah. So now I'm on a version of the main branch, the master branch, that doesn't have that last bug fix. And I'm going to pop in here and add a xUnit test project, which I don't know why it doesn't show up in the top results here. I don't know. All right, but yeah, we want one that runs on .NET Core. Yes, I think all our stuff is .NET Core right now. So I normally put this, I'm not sure about my directory structure. I usually have like a source and test directory, but everything's just under the top level here. That's fine. I'll just call this a unit test. Yes. So this is my bad that I didn't have this test code in here before. And the reason for that is, like I said, I've written several TCP/IP applications in the past. And I have always added unit testing for my parsing logic. So if you go to that blog post that I have on message framing, actually it's the one on length prefix message framing, isn't it? Oh, of course. That's my local host. Okay. If you go to the sample code, and you look through like this code very obviously needs unit tests, right? It's massive. This is literally just reading length prefixing, and I think that's it actually. It's literally just doing a 4-byte unsigned length prefix. Yeah, and then it just passes along. Here's your message just as a byte array, right? So this is just doing that length prefix and then getting the entire message into a buffer, and that's all this code is doing. It's not doing any other message parsing, and just this code is fairly complex. And so this is what normal socket parsing code looks like if you're not using pipelines. And so this code, I've written very similar code to this 2 or 3 times as I've written different TCP/IP applications. And I always have unit tests for this code. It's so complex. So I really should have known better with this project. Even though I'm using pipelines and our parsing code is a lot cleaner, I still should have had some testing code in here for this. So let's see. Let's go ahead and add that now. And I'm going to pop on my unit testing. We'll just go ahead and start this and keep it running off to the side here. All right. And let's see. Actually, so what I want to do is, I don't really care about this pipeline socket type. The pipeline socket is more of a, if you've read about, what's it called, clean design, which I think is not a great name, or the ports and adapters architecture. Pipeline socket is more of an adapter. It just takes a socket, like a literal socket, and converts it to a pipeline API. So I'm not planning to test that. This is the kind of thing that's more like integration tested. What I really want to test is the parsing code in here. And this chat connection, as I talk about in the README for the project now, this chat connection is now starting to take on several different responsibilities. It's got the parsing. It's also got several other things like handling keep alive messages and that higher level API of when we set a nickname. And so it's actually got several different things, kind of bundled in the same class, and I'm starting to feel a little bit nervous about that. I don't know if nervous is the right word, but this is starting to get to where it would be nice to break this up a little bit. But I think I can get away with not doing that today. So what I really want to do here with this chat connection type is its APIs are all fine, except for what it wraps here. I'm going to want to abstract this out and provide my own kind of stub in here. So I think, actually, so the pipeline socket, the normal thing, or the main things it provides is, the socket, which is just exposed here, and the remote endpoint. We don't really care about those for our testing. And then it has a input pipeline and an output pipeline, and those two are the main things that we want to use in our tests. And this might be a use case for iDuplex pipe, actually. That interface in pipelines that I'm not sure if anything actually uses. And they use input and output. Okay, I like that. I might use this iDuplex pipe interface. Let's go ahead and do that. So, okay. So I can add an iPipeline socket because I'm going to need to extend it. Let's see here. So let's just cut this iPipeline socket. This is really just for testing, but I'm going to make it public anyway. And we can go ahead and use iDuplex pipe off of that. All right, and then what else do we need? A socket. New. Just a socket. Thank you. I guess I don't need public. All right. And what else? I do need a namespace though. Oh, there was something else. Well, as soon as we stick it in, everything's going to break. So we'll see what happens very quickly. So if we make this an iPipeline socket, and then of course our pipeline socket has to implement that interface. Okay, then we've got and I'm just calling it input pipe and output pipe. It's actually, I believe, input and output. I'm just going to have it implement that interface and then fix it. All right. Right on. So we've got that input, which is a pipe reader. So instead of input pipe, I'm just going to change this to the iDuplex pipe style of this. So we've got our output and input. I'm just going to go ahead and delete these. We'll change those upstream. And what else? I don't know if anything's actually needing this max message size outside of this type. It is. Okay. So we're also going to need this max message size in the remote endpoint. And if this was a real world application, you might want to clean this up a little bit. But I think that's good for me, just as an example. All right. So now we've got this, we're going to pass in this pipeline socket. So we've defined, these should be all we need for our interface. We're implementing it with our pipeline socket. And now I'm going to consume it as an iPipeline socket here and remove any kind of notion of the actual pipeline socket type from anywhere else in the code. So this becomes an interface, and then that'll break some other things. Let's jump down here and see what we got. So our output pipe is now just output because I'm using that duplex pipe interface. And same thing with the input pipe. Is that it? Boy, okay. That might be it. All right. Builds fine. Now we have an interface that we can actually stub out in our unit tests. So what I want to do is first let's just make a unit test that takes our that really just writes one. Okay. I think I'm. So let's create a stub type here. This is going to be their fake pipeline socket. And of course, we don't have any project references or anything in here. Okay, yeah, add reference to chat API. That's what I want. Okay, sure. And let's implement this interface. Okay. So what I'm actually going to do here, I don't care about socket because nothing's actually using socket. So I'm going to kind of just cheat a little bit and say it's null, but it's also not null. Our max message size, similarly, nobody really cares. That's not what we're testing with this. So I'm just going to set that to some relatively high value. And our remote endpoint, same thing. No one cares. Is there a... There's not like a local address off of this? Look back. There we go. We'll just say that. So if anybody reads it, it's just going to come back as nothing terribly useful. All right. So we've got, these are the ones that nobody really cares about. What we care about is our input pipe, and our output. And what we want is, so I'm actually going to want like a pipe for the input and a pipe for the output, and then I want to expose also for my fake class the other sides of those pipes. I'm trying to keep an eye on the chat, so if anyone has any questions or comments, go ahead and jump in. So now the real question is how to name these. And this is going to be, I'm going to keep the input and output naming. I think that'll be clearer. So this will be input, and actually, you know what? We can just new these up, and the default sizes should be fine. Our test messages are not going to be huge. That's not what we're testing at this point. Okay, so then our input becomes input.reader. Our output becomes output.writer. And then what we really want to expose for the tests is the other side of this. And actually, for our tests, we don't want any of these to be implicit implementations, just to make sure that we are always using the correct side of each pipe here. So now we want to expose the other sides of each of these pipes. So this is going to be the pipe writer. So this is going to be the, what do I want to call this? The input writer. Yeah, I'll call it that. Which is input writer. And similarly, pipe reader for our output reader. I'm wondering if I want to actually tie these together, and I don't. That's going to make this a little bit more complicated than I wanted. But you know what? That should still work. Okay. We'll see. So I'm going to do my fake socket here. And what I want is my connection, which is my system under test. And I'm going to be passing in my fake socket, and I want to disable my my keep alives. Right now, hey everyone, there's Freddie and Lars in the chat. I want to disable my keep alives, and right now I've allowed that in the chat connection type. You can pass timespan.infinite, and it won't actually ever send any keep alives. I think I allowed that anyway. So this is, I think it's off the timeout class, which is always kind of awkward. Or timeouts or something. There's an infinite time span, but it's not off of the time span type for some reason. Well, it's under system threading timeout, which is not a great place for that, but oh well. All right, so I've got my fake socket. I'm passing it to the connection. Now what I want to do is I want to start reading messages, right? And I want to, actually let's just do a simple test to begin with. So I'm going to say, here's my messages, and I'm going to take my connection, and I want to take the input messages from that. And I don't want to await for each over this because I'm controlling both sides from the same method. So what I want to do is start this off, you know, and of course, what I want to do is start collecting all the messages, and then I'm going to check them at the end. So I don't want to await on this right now. I don't want to have an await for each. I can write my own. I'm trying to decide if I want to use the system link async, or if I just want to have my own little local method. It's not a big deal. No, I'm gonna use the system link async project. So when you're dealing with async enumerables, one thing that you often end up needing is like some asynchronous link methods, and those are not out of the box, but there is a package for them called system link async. And this is, in spite of the name of the package and the name of the namespaces, this is not actually managed by Microsoft, it's managed by the community. Not that that really matters for us, but okay. So we've got system link async, and now I should be able to just do like a to-list async, right? Maybe, if I have the right namespaces. There we go. And this actually returns a value task, I believe. Not that it actually matters, because we're only going to wait it once anyway. But that is something we'll have to keep in mind a little bit in some of our later tests. So I've got these, okay, so I've got this reading now from the socket, from our fake socket, and it's going to just be looking for a message. And I think I'm just going to send it one message just as an initial test. So in order to do that, we have to write a message to the input writer. And this is the harder part now, because I don't really want to duplicate this code in here that is serializing out these messages. I mean, I could, but bleh. Where are we doing that? There's the parsing. Oh, you know what? I forgot. I have those extension methods on there. Yeah, that's not bad at all then. We can do that. So really all I have to do is this code right here. And that's not so bad. Just duplicating that. The other option that I'm thinking is if there was some way to, we could also like have a chat connection that writes to the output. So I could like send a message and then read it from the output reader and then turn around and write it to the input writer. That's the other option that I have here. So I don't know which one would be cleaner. Let's try writing it with the connection. So let's say here's my connection, and I'm going to No, because then we'd still have to detect when it's complete and everything. It's too much, too messy. All right, I'm trying to do too much in one thing here. So I'm just going to paste that in there. This, okay, so I'm just going to have a single message, which is going to be a, we'll just call it a chat message, which is under my messages sub namespace, with a text of hi, and that's all it's going to be. And okay, so yeah, we do end up duplicating more of this code than, which I'm not terribly pleased about. This would be better if it was more broken up. Oh, this message serialization class is all internal, that's why. So, again, there's a couple different ways you can do this. You can, copy some code. You can take a, or with this, with this kind of internal type, you can expose your internals to your unit tests. A lot of people do that. Or you can do what Microsoft calls a pub internal type, which is make it public, but in this internal namespace, so everybody knows it's not really public. I think I'm just going to do the pub internal approach here. So I'm just going to say this is internals and move my message serialization in there. And we're going to change this namespace and fix all the build errors because nothing's going to like that. I did away with that completely. Oh, not you. I don't care about your errors yet. All right. Chat API, those are the ones I wanted. Right. So get me these internals. There. And I'm just going to do the same thing over here. Just call this using static. Yes. Get rid of that completely. All right. So that should clean up our chat API build. And now we've got this public class in here, which then our unit test can use. Alternatively, you can, do that, share my internals with the unit test thing. All right. So now I can actually say, it's not going to give me a helper for using static, but I'm just going to do the same using static here. What's it called? Chat API dot internals dot message serialization. So now we have access to all these message serialization types as well. And you know what? I'm thinking I'm wondering if I should just wrap all this up in a single, yeah, I'm going to do that. Yeah. I try not to have my tests influence my design too much, but in this case, I think that's good. Forget pipeline socket. I don't care about pipeline socket anymore. All right. So we've got our, what I want to do is take that send message async. So when where did I copy that code from? Over here, write message, that's what it is. So this write message, which is only called one time and it's a private method, so that's a pretty good indication actually. We can take this and move it over to the message serialization type. And I'm just going to stick it right on the top here. That'll be fine. This will be, I think, a void method. This will be iMessage. So this will be like one method now just to write this entire message to a pipeline. So this will be a pipe writer. And so it gets a length prefix, it takes the memory from the pipe. It creates a new span writer, writes out the message length prefix, and then the actual message. And this is confusing though, because I've got a write message here, which writes like the body of the message, and this write message here, which writes the entire message, including the length prefix. So I'm going to rename this one. I shouldn't be doing like refactorings within refactorings, but good enough. I'm going to change this one to write message body, just to keep that more clear. All right, boy, we're cleaning up a lot of code today. Okay, so back to the message serialization where I was, up here. And then this other, this also gets replaced with the pipe writer. So this actually writes an entire message out to this pipe writer as a single operation. And it is roughly equivalent to the write message over here, which I'm going to delete now. So we delete that. And then this write message down here becomes a method on our message serialization. So it's going to the pipeline socket.output. All right. That should still be working, and everything should compile except our unit tests, right? Yes. As I was going to copy this code, instead we put it in our message serializer type. So it's going to be much cleaner now. And now we've got some decently clean test code. So now I can say, I want to write the message to the fake socket dot input writer. Yes, I like that. I like where this is ending up. Okay, and then I can. This is my messages task actually, because I'm not awaiting it yet. Our output messages are going to be whatever this gets. Should be messages. And we should, sure, there should be one. It recommends it and then it's like, oh no, you shouldn't do that. All right, fine. Okay. There are ways to do collection assertions for, yes, for this. It contains exactly a given number of elements which meet the criteria for the element inspectors. That's what we want. So we want to take our messages, and there should only be one. So this is our result message. And it should be the same. Yeah, I'm going to say that our. Should I just cast it? I'm just going to cast it. So our chat message of the result, our resulting chat message, should have the same text. Complaining about here. Okay. Some odd kind of argument there. System action. Oh, okay, right. I'm trying to return a Boolean, not actually assert on it. That's fine. Let's see, can we say that, assert that this is a type, and it returns it? Okay, so that's nice. Let's do that. That'll give us a better error message just in case it's not. And then we also want to assert, there's probably a more fluent way to assert this, but whatever. Really? Yeah, okay. Oh, actually that's correct. Because expected is always first in assertions, and I always get that wrong. It's like every assertion library has the expected value first, and Oh well. All right, so this should be asserting, if I've got my assert correct, that there's exactly one message, it's a chat message, and it's equal to hi, as we read it out. Well, let's run it and see what happens. So my live unit testing is already looking at it. Just thinking about it. Sometimes live unit testing can get a little confused, so I'm just gonna kill it. Rebuild the whole project here, and then start it up again. Maybe. Wow, okay. Or not. I guess I can just run it manually. That's fine too. All right, let's go ahead and do that then. Or I could have a bug. That could be too. Windows. Get in there. And then get smaller. Looks like I might have a bug here. Interesting. Does not seem to be completing. What did I forget here? Okay. No one in the chat found it yet. Let's see. Got my fake pipeline socket. Creating a chat connection. I am reading the input messages, and then I'm writing one to the input writer. Oh, this only completes when the socket's closed. Okay, that's what the problem is. All right, let me stop this thing. All right, so what I want to do I want to close it? I don't know if I actually want to close it or not. I kind of want to keep it open. With other tests, I'm definitely going to want to keep it open. So I'm kind of thinking maybe I don't want this two-list async in here after all. And I'm just going to say, instead, let's take our enumerator from our connection input messages. Get async enumerator, yes. And then I want to say get next async, or move next async. That's it. So I'm getting like one element asynchronously, and we'll just get rid of that and await that instead. So that way, it doesn't actually have to. That way, it doesn't actually have to close. All right. Now let's see if this works. Let's build this and what we got here. Oh, because I don't have a collection anymore now. I've only got one. All right, that works. This is I'm going to call this result. Okay. And let's build this. All right, let's run this real quickly first. I want to see this thing succeed. It's not succeeding because I'm not flushing the socket. Boy, one thing after another, right? We'll get this eventually. So the input writer needs to flush. There. Come on. I can't type today. There. Now it should run. Fingers crossed. And it's still not doing anything. All right. What is going on? Wow. Would async task be helpful? Yeah, yes. Yes, thank you. I didn't realize, why is this async void? Did I write that? That should absolutely be async task. Because I don't think xUnit ever supported async void. Anyway. There. Now it's actually completing. Thank you, Freddie. Awesome. All right. Let's see what happened here. So it says, is the type wrong? It got back a Boolean. Oh, right. Yeah, because move next async actually returns a boolean. Silly me. All right. So I'm going to await next message task. That should be true, right? So we should get a message back, and then our actual result is the current off of the enumerator. One of these days, our first simple test is actually going to be correct. All right, there we go. That should work. Maybe. All right, good. Whew, that was a long ways. Okay. All right, let's jump over to our live unit testing now, kick that back off again, now that I've got a basic one working. All right, so I'm serializing one message and being able to read it, one complete message at one time. So the next step is what I want to do is what I usually test with my parsing code is I'll take like one message and write it 1 byte at a time. So like all the bytes are arriving in different packets, is kind of what you're simulating. So that's what I usually test. And then also test one where you get multiple in one. And then also it's a good idea to test if so you put like two messages in one. And then it's also a good idea to test if you have like a 1.5 messages and then the rest of the second message, just to make sure that extra buffer is preserved. So those are all good test cases. Let's go ahead and start working through those. Let's put in should we do the failing one next? Let's do the failing one, because we know that this, I should name my test method better. So this is a simple message. And this is going to be 2 messages. And in this case, I can actually just send the same message exactly twice. And then, surprising, it's already failing. Wonder why it's failing. Oh, right. It was failing because of that bug in the code, because I backed out that fix. So then we get, oh, hey, you get that invalid exception saying no reading operation to complete. This is the one that Michael had found. So we have a failing test here, and actually our test isn't even quite complete. Kind of thinking I might just want to clean this up a little bit. So we've got our enumerator. Instead of just breaking this out into a separate task, because we don't actually need to start this up here, since we have an enumerator. Actually, I'm just going to move all this down here. That should still, that still passes. I'm going to do the same thing down here. Because what I want to do is have one message, oops, come here, you, and then the second message. All right. So this is actually what I want the complete thing I want to be done here. All right, so we have we've now reproduced the bug in a unit test. Good. Now we can fix it. So I can cheat a little bit because I already fixed it. Right, so our code here, the problem is we're calling advance to more than once for the same read async block of memory. So that is a bug in our chat connection type. The one nice thing, or not the one nice thing, but one of the nice things about live unit testing is it gives you code coverage here. I don't know if you've been noticing this, but this is the blue dashed lines are just not covered. And then the red X lines are, hey, this is covered by a failing test. And then it also has green check marks. I don't see any in here. It also has green check marks for code that is covered by only passing tests. So you can see that with the test code, at least up here, showing the green check marks. So this this lets you see. Sometimes it helps you like really tighten down and see where the code is failing. So we've got this method here, which is some passing, some failing unit tests. Okay, so let's see. I'm just going to search for my advanced 2 because I know where the problem is. Advanced 2 is the one that's throwing here. And yes, so this code is in a failing unit test. It also has a passing unit test down here. You can see where it's correctly returning the result. So it is being called by both unit tests. All right, so let's go ahead and fix this. I'm going to fix it here, and then I'm going to move the fix out, I think. Yeah, I'm going to do that. Okay, so the thing that we want is, I'm going to jump over here so I don't have to think through this again. So before we were taking this begin of message position, all right, and then advancing it each time we read a message, and that's what's wrong. We only want to call advanced to once. So I fixed this just by introducing this consumed position instead, which I like. And then after we read each message, I just update that consumed position to the current position. That sounds really good. That sounds better. Okay, so we've got, let's just do the same thing. Consumed position, which is going to start off just at the current position, right? Yeah. Then we don't need to keep track of where the begin is anymore because the consumed is always going to be there. So I can move this code out to the end and say I'm going to always advance to the amount we consumed, and then we've always observed to the end of the buffer at the end of this method. That's always true. So now this is just a plain break. And then this is the other one that needs to change here. This cannot advance here, but we can advance our consumed position. Equals sequence reader dot position. Yeah, exactly. Okay. So I think that is correct. And boom. You saw the live unit testing like immediately run those tests, rerun the failing tests, and yep, it's working now. Actually, it reran both of them because they both go through this method. So now I'm confident, yes, my code is now working for both of those situations. Okay, so let's see. Sorry, my mind is trying to jump ahead to my next unit test. I'm like, no, I want to fix this first. The one thing that I don't like about this this solution, which is, I haven't been checking in, my bad. Okay. I should have checked in when I did the, just by adding the unit tests, but this will be good enough. Add unit tests and fix bug. I like to check in my unit test first and then fix the bug as like a separate check-in, but I forgot to do that. Okay. So now we've got that essentially the same bug fix that's in here that we've developed with a failing unit test, or fixed with a failing unit test. The other thing that I'm not really pleased about with this bug fix is this advanced to, because I want this advanced to be in the same method as the read async. So when we call this read async, what I really want is for this, what I really want is for the advanced to be right next to this read async. So we call read async, we parse out the messages, then we call advanced to in the same method. So it's very clear there's a one-to-one correlation there. So what I'm actually going to do, and this is a little bit ugly, but you know, good enough. I'm just going to return that consumed position here. And this was a sequence position. Just going to, running off the screen there. All right, so now I'm going to return, instead of calling advanced to on the pipeline, I'm not going to do that here. And it always advances up to the buffer end, so that's fine. I'm going to return my resulting messages along with the consumed position. Okay. So now, let's jump back to where this is. I can say, parse messages data.buffer. Okay. And then I can actually advance that pipeline socket right here. So this read async and this advance to are right next to each other in the code, and I'm not going to be making that mistake again. So this becomes data.buffer.end. We've observed to the end of the buffer, and then I can for each over each of my messages that were returned. Automatically runs the unit tests. They passed. Awesome. All right. So this I like a little bit better. And I'm just going to go ahead and check this in here. Refactors. So read async and advance to are in the same method. Just making the code up better. And then what's the other one? Get memory. I just want to check our reading side. That was get memory, isn't it? Get memory. Where's my parsing code? Oh, right, we took that out. I just took that out, and that's in the message serialization type now. So the get memory and advance are also in the same method. Good. All right. Get that ping pong style more clearly correct. Okay, so we've got, should rename this unit test type to chat connection tests. Should have done that at the beginning. All right. So we've got just a basic, here's how you can parse a message. Here's how you can parse two messages. I'm going to change this to and change this to parse two messages. And one other thing that I'd like to do, I don't know if I'm going to have time to finish this today because I'm not that familiar with the pipelines API, but what I'd like to do is parse one message 1 byte at a time. So in order to do this, what I have to do is kind of like intercept that, intercept this here and get these bytes out. So what I really want to do, I can call write message just on a different pipe. I might do that. So I'm going to new up a pipe here, and I'm going to write my message into here. And then I'm going to close this pipe. Does complete do a flush? I'm not sure. I'm going to do a flush just in case. And then I'm going to mark it as complete. And that didn't, oh, right here. And now I'm just going to read everything out of the pipe. So I just want it like literally just as bytes. And I don't know if I can do that very easily. There's a copy to. There's a read async. You know what I'm going to do? It's test code, right? So it doesn't really matter. So I'm going to read, I'm just going to grab it as a stream and say read all bytes. That's not the thing you can do with streams. Surely I can read all the bytes from a stream. Really? Okay, sure. There might be a more efficient way of doing this. It's been a while since I've actually worked with streams a lot. I want to read this out as a byte array. And I'm having kind of a hard time doing that just with a base stream type. So I'm going to do this. And then I'm going to say Writes the stream contents to a byte array regardless of position. Okay, so I don't have to rewind it. Excellent. So I'm pulling out the bytes here. This is my horrible as far as performance goes code. All right, so I've got the memory stream. My unit tests are going infinite over here because I'm not properly writing this out. So now I've got each little byte. And what I'm going to do is I'm going to write each byte and flush it. This is my super efficient unit test here. So now I'm going to take my fake pipeline socket, and I'm going to take that, no, okay, I had a fake socket, right. So the input writer, I'm going to write, did I do that? Okay, it's always write async, that's fine. And I'm just kind of assuming here that my buffer is big enough, which should be the case for these test messages. Otherwise, you'd want to have a reading going earlier so that as you're writing, it'll be reading already. All right, I've got a read-only memory of bytes, so I actually have to pass in okay, I can do that. We're getting even more inefficient. I'm going to new up an array around every one of these bytes. That works. All right. And then I'm going to flush it. And in this case, actually, so what I can do, and what I've done in the past, is actually start reading earlier, and then write out every byte except for one. Make sure it doesn't complete. Make sure that your task doesn't complete, and then write out the last byte, and then make sure it completes. So that's like you could do that, but I'm confident, sufficiently confident that this flush async is actually writing all. Yeah, I'm sufficiently pleased with this test. And actually, what I'm wondering is if all of these helper methods are now getting returns here. They're not. Okay. Yeah, because what I want is code coverage for this. I want this try read length prefix to return false, and it's not doing that. So it's still, this is not testing what I'm thinking it's testing. So I think I do have to actually start that that read up here. It wouldn't hurt anyway. Okay. So now I'm trying to read a message right away, and then you can't await it again. So there. Now I'm trying to read this message right away, and this should hopefully do that. No, it did not. Interesting, fascinating. Okay. So I'm kind of wondering why this isn't actually. I guess I do have a race condition here. If this is writing and flushing too quickly, I may not actually be passing it to the reads. That's what I'm kind of thinking might be happening here. All right. I am going to jump in here and debug this thing real quickly. And that's still not the right thing. There we go. So if I'm just gonna stick a breakpoint right here and say debug this. I just want to walk through this. See if we're actually getting that. So in our sequence reader, we've got We've got 12 bytes already. Yeah, we're getting the whole thing. Problem is, pipelines is just too efficient. It's designed to be efficient. Oh, right. No, that still works. That's still true because it should be at least getting down to here, right? Because it is going to parse out all these messages. Yeah. Should be getting called right away. Actually, this should be getting called. This should be running right away, even if we're not reading, because it'll be putting them in the channel. That's right. So I'm trying to think of a way. Is there any way I can like force this thing? I hate to put in hacks like this. Like, I think this would work if you just did like a wait task.delay, maybe like a couple hundred milliseconds. I hate putting in hacks like that. I'm just curious if that would cause that code coverage that we're missing right now. Of course, that makes this one test to last like several seconds now. Okay, so it is, getting in here saying, I'm trying to read this length prefix. Oh, so now we are seeing this code coverage where it's getting a partial length prefix, it's getting a partial message. These will never be hit because of this check up here. These other false branches. Boy, I don't like that. That's pretty hacky. It's. I think it would be good enough if we just had the one await task delay, and so I'm gonna structure my unit test like that. This is not ideal, but I don't know if pipelines actually gives us all the knobs that we need to test out exactly what I want to test out. So I'm just gonna say we're gonna write all the bytes except for one to the buffer, one at a time. Oh no, I really like having it actually written one at a time with a delay between each one. And that does mean that I have a unit test that lasts 2.5 seconds, which is horrible, but I think with the API that we have, I'm not sure if I can get it any better. Okay, so I'm pretty confident, or I'm reasonably happy with our current unit test situation here. Yeah, Lars is saying, test delay after each flush. That's not the cleanest way. You're right. What we really want is some way to hook into the pipeline here and say, have you actually notified your readers yet? And I could build that, like if we, in this message serialization type, or actually whatever calls this, it would be in chat connection. So I could say like, hey, I could expose some kind of hook in here, like just for testing code, saying, I have actually run my try read message code at this point. Whether or not that's worth adding is a different question completely. I'm going to leave it as is for now, but feel free to add that in if you want. It should be something that's only accessible from testing code and only visible to testing code. So that's where you might want to make it internal and use your internals visible too. But I mean, you could do like a little, manual reset event or something, or an async one that would say, yep, okay, I called read message again. Which again is kind of hacky, but one of the problems with our solution is because it ends up with these main loops, right, which I've talked about several times. That's where that kind of hackiness often becomes necessary, because you need to know, has my main loop actually done this? And there's no other way to see that. So because of these main loops, you do end up sometimes with some hacky things like that are just for testing the code. I guess, Lars suggested that before I come up with the same thing. Yeah, okay. So yes, just tossing in the task delay is often like good enough, right? There are other options that you can add hooks in. But yeah, the task delay is okay. All right, so we do have the unit test coverage of what I want to cover. Oh, and that's the other thing. Because the task delay is always, whenever you have something like this in your unit test, there's actually always a race condition, right? If this was in a project with like hundreds or thousands of unit tests, I would be much less likely to add a task.delay. And the reason for that is when all of your unit tests are running at the same time, you might just get, if your threads just get delayed because everything else is trying to run on the processor at the same time, that task.delay may not actually cause that code path to be taken. And in which case, you're no longer actually testing what you think you're testing. So actually a better solution would be something like a manual reset event that's exposed from the chat connection type, and that we can wait on in here to say yes, and then you get that lockstep. I've written a byte, I've consumed a byte, I've written a byte, I've consumed a byte, and you get that lockstep going, so you're covering that case. That said, it's after 8 where I am, and I gotta get to work, so I'm gonna leave it as it is here for today. But thank you all for joining me on day 14, the second bonus day. Let me commit the last of the code here. Day 14, add unit test for 1 byte at a time. Normally, I do also like to add one other unit test, and that is, I've mentioned it before, you write one message and part of another message in a single block, and then you write the second half of the second message, and that's just to handle that one. Currently we've got code that tests, writing a single message as a single block, which is the easy case, writing a single message in 1 byte at a time. So you get up to that message boundary again, and then we also have parsing 2 messages at once, but all of our tests right now are ending on that message boundary, well, except for the byte one. But that's just testing one message that way. Actually, let's do that. Because then we could actually just do that in the same test and do it real quickly here. So if we wrote 2 messages 1 byte at a time and we got both of them, that would also prove that case works. What I want to check is any kind of like, well, we've reached the end of the message, therefore drop anything we don't have. Or no, that wouldn't work. Okay, so yeah, what we'd want to do is write like a message and a half in one block, and then have the second half of the message, and that catches that possibility of where we reach the end of the message and then drop the rest of the buffer. We want to make sure that we're not dropping the rest of that buffer. So actually, that is a pretty important use case. I'm gonna just I'm gonna take this and I'm gonna see if I can write that up real quickly. So this is going to be parse 2 messages, and the first one is partial. And in this case, we don't need to have. Okay, so I don't think that the reading up here actually didn't make any difference because we've got that main loop. So I'm just going to move this back over here. Right? Looking for those green check marks. Yes, okay. All right, and I'm just gonna do the same thing over here. And that way, okay. All right, so what I wanna do is write out one message that's only partial, and then write out one message complete. So actually, this is not a good description. So the first block has one full message and then part of the next message. I'm trying to think of an easy way to say that. Has partial second message. All right, we'll call it that. All right. Laura says, it's like Hitchhiker's Guide, 5th part of a 4-part trilogy. Yes. I keep going, I keep going. I can't stop. I'm almost done. I can't stop quite yet. All right, so we still need all of the same binary complex stuff. I'm going to actually say write the message twice, and then flush and complete. And then in this memory stream, I should have 2 messages that are the same. So I'm just going to say the first one is half of the bytes. So when I get the bytes out here, what I want is, okay. So what I want, I'm just going to say, to make this a little bit clearer for my brain, the first message is going to be, what is this, take? Yeah, take, and I'm going to take the first half of them, and then I'm going to skip over that and take, should be arrays, sure. And take, again, this is test code, so I'm like, I'm not even caring how inefficient it is. This is going to be a byte.length minus byte.length over 2 dot 2 array. Okay, so then what I want to do is, actually, okay. I'm going to do this with offsets instead, because I want the first section to contain the first message bytes and part of the second message bytes, which I can do with arrays too. That's fine. All right, so I'm going to say second message, first part. I'm just going to do the same thing here, just divide it up by 2, and then take whatever remains. And we got to skip that. Okay, so that looks right. I'm going to break this up a little bit so I can see it a little clearer. Skipping and taking, and I'm just going to make these the same. Okay, so we've got taking half, skipping half, and taking the remaining, taking half and skipping half and taking the remaining. Okay, so I've got it like this. So here's my first, I'm going to call this packet. Technically it's not packets. We all understand that at this point. I'm going to call it group then. First byte group, sure. The take after the skip may not be needed just to get the rest. Thank you, yes, that's a great point. So I don't even need that. All I need to do is skip on both of these. Toss on a 2 array there. Okay, thank you. All right, so then we've got our first byte group being the first message bytes completely. And then we are sticking on, I don't want append, I want concat. Not contains, concat, thank you. And then we're just going to do the second message first part, right? Toss those into an array also, because I just love being efficient. Okay. They can match the other ones. All right. And then I'm going to take this. Actually, we only have 2 writes then, which is fine. I don't mind that at all. And I'm going to, so the first byte group is going to get written first. Just going to dump that in there, flush it. We're going to wait a couple milliseconds, and then we're going to write out the second byte group, which is just the second part of the second message, and flush that as well. And then we have 2 messages coming out. They should both come out. Moment of truth. All right. It ran, it passed. Good deal. All right. Now I'm very content with our state of unit testing now. Add more unit tests. Okay. At least for that part of the code, right? The rest of the code is completely untested. use it your own risk. Okay. So let's go ahead and stop our unit testing here. We don't need that anymore. Just going to take a look at what changed, which I can't tell because I renamed the file. My bad. Oh well. Okay, so I'm going to go ahead and commit this. I'm going to completely overwrite the change that I did before. So this commit is actually going to go away. And yeah, let's see here. It's probably not a bad idea just to run them manually and just, make sure it is actually working. Because there's a lot of this code that I'm not testing too. So here we go. We're going to connect up here and connect, and I can send a message, and I can set my nickname, and I can't set my nickname. Right. And then I can send a message as Bob. Yeah, looking good. All right. Disconnect. All right. And suddenly fail. Everything seems to be working. All right, so I'm going to git push. I'm going to force push to my master branch. Yeah, okay, don't do this at home, kids. All right. There. And now we should have, some better unit testing. The one unit test is a little bit long and uses task.delay, which is not ideal. This one does too, or the latest one does too. But it works well enough. So so thank you all for joining me again on the second bonus day. This has been day 14, and it's been fun. As far as I know, I'm not planning to do any more of these unless someone finds some more bugs. Then I'll have to revisit them. But thank you all, especially people in the chat helping me out with this. That's been very helpful, and it's been fun. We will see you around.